Alright, now section 11.6 is about properties of logs. So we'll review some of the properties of logs and then we'll introduce new ones. Let's do a review first. The first one, we know that log base b of 1 is 0. Again, if you look at the exponential, it's b to the 0 is 1, which means log base 10 of 1 is 0 because 10 to the 0 is 1, which means ln of 1 is 0 because e to the 0 is 1. The second property of log, to review, log base b of b is 1, again because b to the first 1 is b, first power, which means log of 10, and then ln of e is also 1. And then the third property is if we have the bases are the same, they cancel out and you get x. So log of 10 to the x is x, ln of e to the x is also x. Again, these cancel out. And if we reverse that, b log base b of x is x, as long as x is greater than 0. So 10 to the log of x is x, and e to the ln of x is also x. Again, x has to be positive, otherwise it's undefined. So if you look at page 972, number 20, if we want to evaluate log base 9 of 9, log base b of b is 1, so that's 1. Again, you can check 9 to the first power is 9. 24, 8 log base 8 of 10. Again, the 8 log base 8 cancel each other out, so you get 10. 28 log base 7 of 1. Any base, as long as the input is 1, that's a 0 because 7 to the 0 is 1. So now the new rules of logs that we haven't seen before. The first one is called the product rule of logs. So let's start with an example. So if I have log of 6, I'm using base 10 so we can check it on the calculator. Does it equal log of 2 plus log of 3? So let's check that out. So find log of 6 on your calculator and find log of 2 plus log of 3. And you can see they're exactly the same. And the reason is because 6 is actually 2 times 3. So log of 2 times 3 equals log of 2 plus log of 3. You can try it for as many as you want. So basically, as a general rule, log of x times y equals log of x plus log of y, and it can be to any base. It doesn't just have to be to base 10. This is called the product rule. We also have the same thing for quotient, the quotient rule for logs. So for example, is it true that log of 3 halves equals log of 3 minus log of 2? Let's check that out. Log of 3 over 2 inside the parentheses is 0.17609. Log of 3 minus log of 2 is the same. So remember, log of 3 half does not equal log of 3 divided by log of 2. You can see you don't get the same answer. Compare log of 3 halves and log of 3 over log of 2. So this does not equal log of 3 divided by log of 2. It equals log of 3 minus log of 2. So that's why we have what we call the quotient rule. Log of x over y is log of the top minus log of the bottom. So the negative has to be in front of the log of the bottom. Any base b as long as the base is greater than 0 and different from 1. Okay, so as an example, so if I say expand as much as possible, and I give you, say, log of 3xy, well, this is product rule, so you can do log of 3 plus log of x plus log of y. Okay, there's 3 times x times y, so they do that. Now if you have, say, log of xy over zw, again, since it's division, so we change it into subtraction, so log of the top minus log of the bottom, but this is product, so it's going to be log of x plus log of y minus, again, that's a sum, log of z plus log of w, but then the negative will change all these signs. So log of x plus log of y minus log of z. And I don't know if you noticed, the z and w are denominators. They will have a negative in front of their logs. Always. That's always the case. Okay? Okay, then the third rule, which is called power rule for logs. For example, if you're doing log of 8, it's actually 3 log of 2. Let's check our calculator. Log of 8 is 0.90308 and so on. 3 log of 2, it's exactly that answer. So why is that? Because 8 is 2 cubed. And when you have an exponent, you can times it by the log. That's what this is about. So the rule says if you have log of x to the r, you can take the r and times it by the log. As long as this is defined, meaning x has to be greater than 0 in this case. Okay? So for example, you can use the power rule to simplify this. Look, square root of 2 is 2 to the 1/2. And we can take the 1/2 and times it by the log. And we know that that's a 1. So it's 1/2 times 1, which is 1/2. Okay? So now let's expand as much as possible. Expand into multiple logs as much as possible using the 3 rules that we talked about, which is the product rule, the quotient rule, and the power rule. So if I have ln of x cubed y squared over w cubed z4, the first thing I want to do is the quotient rule. So I would write this ln of the top minus ln of the bottom. Okay? That's the quotient rule. Then I would do the product rule. So it would be ln of x cubed plus, product changes into a plus when you expand it. And then minus, same thing here, product changes into a plus. But keep in mind you have a parentheses around this. So this would be negative ln of w cubed minus ln of z4, just like I talked about. These are in the denominator, they're going to have negative in front of their logs. This is ln of x cubed plus ln of y squared. And now the power rule says each power has to be multiplied by the log, assuming all these logs are defined. Minus 3 ln of w minus 4 ln of z. So we learn how to expand. Now we should learn how to go backwards. So going backwards, we're going to put the power back. Then if you have a plus, that makes it in the numerator. If you have a minus, that makes it in the denominator. So that's what I'm going to show you next. I would say condense into a single log a single log. So if I give you multiple logs, how do you condense them into a single log? -3 log of x plus 4 log of y minus 3 log of z minus 4 log of w. The first thing I would do is put those numbers back as powers and keep the sign. Don't move the sign with them, okay? Because that was the last thing we did when we were expanding. So negative log of x cubed plus log of y to the 4 minus log of z cubed minus log of w to the 4. Now I want to write this as a single log. So I'm going to have a fraction because there's some negatives. For every log that has a negative in front of it, its input has to go at the bottom. So x cubed should be on the bottom. For every log that has a plus in front of it, its input has to go on top. This is negative, it goes on the bottom. And this is negative, it goes on the bottom. And that would be your answer. Okay. Next, we're going to talk about what we call the change of base formula. We all know that the calculator has two built-in logs. It has log base 10 and ln. Well, can we do, say, log base 2 of 8 on my calculator, or any base other than 10 or 8? We can. There's a formula for this. We know log base 2 of 8 is 3. Why? Because 2 cubed is 8. Now, if you do on your calculator, if you do log of 8, log base 10, over log of 2, or if you do ln of 8 over ln of 2, guess what you're going to get? You're going to get 3 in either case. Let's check. So we're going to do log of 8, log base 10 of 8 divided by log of 2, and it's 3 as we thought, and then ln of 8 divided by ln of 2, which is also 3. So what that tells me, if I want to do log to any base other than 10 or e, this is what I could do. So if I want to do, say, log base b of x, and b is neither 10 nor e, I could do log of x over log of b, and now I do base 10, or I could do ln of x over ln of b. For example, if I want to do log base 3 of pi, for instance, there's no way I could do this on the calculator unless I change it into either log over log or ln over ln. So if I do log pi over log of 3 and put it in my calculator, excuse me, so log of pi divided by log of 3 is 1.0419. So now we can do log to any base using the change of base formula. Excuse me. So number 98, page 973. 98, page 973. How do we evaluate log base 1/2 of 6 to 4 decimal places? Again, you can do log of 6 over log of 1/2. So log of 6 divided by log of 1/2. And it's negative 2.5850 if you do 5 decimal places. I mean 4 decimal places. Okay. Now if you look at 108, it says, page 973, It says find the pH of pickles. The pH is actually negative log base 10 of the concentration of hydrogen ions in sour pickles. So pH is negative log. We're given the concentration is 6.31 times 10 to the negative 4. So we plug that into our calculator, negative log base 10, that's what the formula says. Negative log base 10 of 6.31 times 10 to the power negative 4, and then we do parentheses to close that, and the pH is 3.2 roughly. A pH of 7 is neutral, less than 7 it's acidic, greater than 7 it's basic. So that's very sour because it's very acidic. Okay, that's what this means. So that ends 11.6.